Hello, students. Mr. Kaczynski with you, and today we're going to get through problem 4.1 of our book, Thinking with Mathematical Models. And the name of this lesson is Vitruvian Man. So you all have a note sheet that's been given to you, and what I want you to do is take notes kind of as we're working through this, and then I'll get you practice in at the end of it, okay? So there might be times too where I tell you to pause the video, so do that. But here's the situation. More than 2,000 years ago, a Roman architect and writer named Vitruvius found patterns by relating two body measurements. He claimed a person's arm span is roughly equal to their height. Okay, that's interesting. Do you think the relationship between arm span and height applies to students in your class? How would you display and analyze data collected to test this claim? So here's what we've got. We've got a table of values here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 students. And we've got their heights and we've got their arm spans, and we're gonna analyze that data to see if it supports Vitruvius's claim that arm span and height are roughly equal. Okay, so first things first is we're gonna plot the height and arm span data on a coordinate graph. The resulting graph is called a scatter plot. Okay, so let's graph this data. So to do that, so we're going to start using our note sheet here. All right, I've got the data over here. Okay, so we had one student whose height is 56 and their arm span was 54. So let's go 56, 54. So this is one student who's 56 inches tall and 54-inch arm span. Okay, let's keep going. So we got that one. Let's do this one, 57 and 54. So 57 and 54. That person's a little bit taller, same arm span. And then 57. Oh, oh boy, I messed that up. Let's go back. It was 57 and 57. All right, 57 is right there. So you should be plotting these along with me. And 57 and 54 is right there. There we go. And then 58 and 61 right there. You can pause, or if you want to do it yourself and then speed ahead just to compare yours. 59 and 56 there. And then 60 and 58. 60 and 59. And 60 and 60. So those students are all the same height, 60 inches, but they all have different arm spans. 62 and 62. 64 and 63. There. 64 and 62. 66 and 62. 67 and 65, which is right there. And 67 and 67. 67 and 69. And our tallest person, 68 inches, with a 67-inch arm span right there. All right. So we got these 16 dots represent 16 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 students. Got it. All right, what next? Do you think the scatter plot supports the claim that arm span and height are about equal for most people? Pause the video, write down some thoughts. Pause the video and just write down a sentence or two. Okay, you're back. I mean, I would say yes, that they're, are about equal. Okay, not perfectly, but about equal. The data kind of falls in a straight line. It's not horrible, but I'd say maybe closely. Okay, they're definitely related to each other. Okay, the taller a person is, the longer their arm span. There's no debate about that. All right, if each student in the class had arm span S equal to height H, what equation would relate these two variables? That would be height equals arm span. Oops, we're using S. So height equals S. All right, graph this equation on your scatter plot. Okay, well, let's do that. It would be like this 50-inch tall person has a 50-inch arm span, this 52-inch person, this person, they so it's a line that goes through like perfectly diagonal through all these points. Or maybe it's got a y-intercept of 0 and a slope of 1. So I'm going to draw that line. Just that line right there. There we go. So that's S equals H. I think we should probably label that too. Let's go. Start S equals H. That's that line. Okay. Next, which data points does your line pass through? Which data points does our line pass through? Let's look at this here. I see this one, which is 57, 57. I see this one, which is 60, 60. And I see one more, which is this one right here. That's at 62, 62. Explain how arm span and height are related in those points. All right. How about this? The arm span and height are equal for points on the line. That works, doesn't it? The arm span and height are equal for points on the line. Explain how arm span and height are related for points that are not on the line. I mean, so let's look at some other values here, like maybe this one here. That's 0.5861. And this one right here, which is 6769. So let's talk about those points here. About points above the line represent students who, let's see, that's height is short, whose height is shorter than their arm span. Or how about this? Students whose arm span is shorter than their height. No, whose arm span is greater than their height. That would mean points below the line represent students whose arm span is less than their height. Change the color on this. Let's go with like a light blue right there. I'm going to show a couple of those points too. Like this one right here. This is, his height was 66 and his arm span is 62. So his arm span is 4 inches shorter than his height. And this person right here is a relatively shorter person. They're only 57 inches tall, and their arm span is 54. So 3 inches shorter than their height. All right, I think we kind of nailed all these. All right, what next? The tallest person in recorded history was Robert Pershing Wadlow. At age 22, he was 8 foot 11.1 inches tall. His arm span was 9 foot 5.75 inches. Where would you plot the point for his height and arm span for would the point be on, above, or below the line you drew? Okay, so pause, put down your thoughts, and then click play again to see my thoughts. See, what I think I'm going to do is I'm going to put in all these heights real quick. 56, 57, 57, 58, 59, 60, 60, 60, 62, 64, 64, 66, 67, 67, and then 67 and 68. And then I'm going to put in their arm spans, 54, 57, 54, 61, 56, 58, 59, 60, 62, 63, 62. Should have had this done before I started recording, huh? 62, 65, 67, 69, and 67. Oh, mess that one up. 67, 69, 67. Now we got them all. So if I go to my window and I go 50 to 70, scaled by 2s, and 50 to 70, scaled by 2s. Turn that on. There's my graph. Okay, same thing. All right, and if I graph this, it would be y equals x. Boom, there it is. Now, if I wanted to put Robert Pershing Wadlow in there, I'd have to go stat edit. What was his height? He's, oh boy, I messed this up. There we go. He is 8 foot 11.1 inches tall. So I'll go 8 times 12 plus 11.1. He's 107.1 inches tall, and his arm span's 9 foot 5.75. So I'll go 9 times 12 inches plus 5.75. Now, if I hit the graph, that's his arm span. I'm not going to see it on here, okay? But if I go to window, and let's adjust this out. Let's go to 120 max and 120 max. Now we can see him. And there he is above the line because his arm span is longer than his height. You know, he's got over a 9 foot arm span. So we should write that in here. His point is above the line because his arm span was longer than his height. Does it support the claim that arm span and height are roughly equal? I mean, it's a little bit further away. I mean, if we go back into that table, you know, it was 114-ish. I mean, kind of, but not really. His arm span is almost, well, yeah, almost 7 inches more than his height. So, I mean, but he's kind of close to the line, just like these people. I mean, he's a little bit further away from the line, but he's not like some 8th grade student that we measured his height and arm span. He's the tallest person that ever lived. So, I mean, he's really tall, and I don't know, maybe the difference that difference in his arm span to height. Maybe it is kind of proportional for a normal human. There's something there. It's still close to the line, even though it's way out there. All right, what do we got next? The accuracy of fit for a linear model is measured by calculating errors from the model. These errors, called residuals, are the differences between the actual data and what the model predicts. Find the arm span residuals using the model S equals, it should be H equals S, height. No, it was S equals H, wasn't it? Arm span equals height. I messed that up. No, I was right. Arm span equals height. Is that what we wrote on this one? Nope, I got it backwards on this one. That's what we did wrong. So we should fix this one. 3A should be arm span equals height. All right. So let's calculate these residuals here. So I'm back here on the graph on the front page. There we go. So where are these numbers coming from here? 56 minus 54 is negative 2. 57 minus, I'm sorry, 54 minus 56 is negative 2. 57 minus 57 is 0. 54 minus 57 is negative 3. 61 minus 58 is 3. 56 minus 59 is negative 3. 58 minus 60 is negative 2. 59 minus 60 is negative 1. 60 minus 60 is 0. 62 minus 62 is 0. 63 minus 64 is negative 1. 62 minus 64 is negative 2. 62 minus 66. 65 minus 67, 67 minus 67, 69 minus 67, and 67 minus 68. So I'm seeing these 4 zeros. How many points were on the line? Yeah, 4, right? There were 4 points on the line. So those 4 points are the 4 people. Those 4 zeros are the people whose actual height is equal to their actual arm span. Okay. All right. So it asks us to do next. To see if there's any pattern in the residuals that helps to plot the height to residual data. Oh boy. I think they're talking about this. They want me to put these residuals into my list and graph them. Okay, that's fine. I'll do that if they want me to. Let's do it. Negative 2, 0, negative 3. 2, 0, negative 3. Negative 2. Oops, not there. Let's go here. Yeah. Negative 2. There we go. Now we're running 0, negative 3. 3, negative 3, negative 2. Negative 1, 0, 0. Negative 1, negative 2, negative 4. Negative 2, 0, 2. And negative 1. I guess they want me to make a scatter plot that does the heights, which is in L1, versus the residuals, which is in L3. So I'm just going to go zoom 9. Oh, dimension mismatch. Why? Oh, yeah. So we got to do, I got to get Persian Wadlow out of there. Let's just delete that. Delete that. There we go. Now let's go zoom 9. There we go. So there's our 4 zeros that are all on the x-axis there. And I don't know. I mean, this doesn't show me too much. I mean, it's really not much difference than looking at this graph. I mean, how many blue points do you see underneath that purple line? Most of the students. Okay, I only see 2 students whose arm span is greater than their height. So I don't know. this line's not that great. I think I'd rather have it look, something like this. Wouldn't that be better? I think I like that line better. Because now I've got 1, 2, 3, 4, 5, 6, 7 points under. Get rid of some of this garbage here. Oh no. I don't want to get rid of all that. I guess I can't really. 1, 2, 3, 4, 5, 6, 7 points under. 1, 2, 3, 4, 5, 6 points above. See, that's a lot better. I'm still fitting the trend, and I've got more points above, same number of points above and under the line. All right, let's to see if there's any pattern in the residuals that helps. Yeah, we did that. Yeah, so let's say this. How about the model isn't very good because there are so many more negative residuals than there are positive residuals. We want an even, we want the same number of points above and below our model, our line. That's what our model is, okay? Again, you can pause this and write that into your note sheet. T-Rex grew to be 20 feet height and an arm span of about 10 feet. Do you think that he fits this model? Let's look at him. Let's go to T-Rex. Let's go stat, enter. Let's go here. Put him on here. He's 20 feet tall. 20 times 12 is 240 inches. And he's got a 10-foot arm span. 10 times 12. His arm span is that long. 120. Okay, let's look at him. Let's go stat plot, enter. Change this back to L2, second 2. Let's go zoom 9. So there's the students. Or we could go like this. How about 50 to 250 and 50 to 250. So there's all the students. Remember, they were pretty close to the line. What's his residual? What's T-Rex's residual? It's negative 120. I mean, his arm span is 120 inches less than his height. Okay, so absolutely he does not fit well. Let's put that in here. T-Rex does not fit the pattern at all. His arm span is way smaller than his height. Still a huge arm span, bigger than you and I, right? But, all right, so if you plot the point, would it be above or, way below? T-Rex is point would be way below the S equals H line. And then I want to do one more thing, and I want to test a new line. Let's go back to our data here. And remember, these were predictions for S equals H. I want to do predictions for S equals H minus 1. What if we add a row right here? If we just took somebody's height and we subtracted 1 from it. So 56 minus 1 is 55. And then should I extend this a little further? I'm just kind of extending this table. Let's add a couple rows. So 57 minus 1 is 56, and 57 minus 1 is 56, and 58 minus 1 is 57, and 59 minus 1 is 58, and 60 minus 1 is 59, and 59, and 59. And 62 minus 1 is 61, and 64 minus 60 or minus 1 is 63, and 63, and 65, and 66, and 66, and 66, and 67. So maybe it's not that they're equal to each other, the height and the arm span. Maybe it's that the arm span is one less than the height. So now I can check residuals for that. So I would do their actual height minus their predicted height. Instead of -2, now this is -1. So actual minus predicted is +1 instead of 0. Actual 54 minus the 56 is -2. 61 minus 57 is 4. 56 minus 58 is -2. 58 minus 59 is -1. 59 minus 59 is 0. 60 minus 59 is 1. 62 minus 61 is 1. 63 minus 63 is 0. 62 minus 63 is -1. 62 minus 65 is -3. 65 minus 65 is -1. 67 minus 66 is 1. 69 minus 66 is 3. And 67 minus 67 is 0. So now, like, how many zeros do we have? 1, 2, 3. Okay, we only got 3 people that fit that model perfectly. How many negatives do we have? I'll use like orange. We got 1, 2, 3, 4, 5, 6 negatives. How many positives? 1, 2, 3, 4, 5, 6. We actually had 7 negatives. 7 negatives, 6 positive. That's better. That's what I was trying to say about this graph. You know, if I moved the line down a little bit, and that's kind of what I just did right here. So one last thing here, y equals, instead of doing x, I'm doing x minus 1. Let's forget about T-Rex, and let's just go 50 to 70 here. See, I think that's a much better model, don't you? It's much better. Okay. Hopefully you got all those notes, and you can go ahead and do the practice that I've left you in Delta Math at this point. See ya.